All right, guys, let's talk about acids and bases. This is the first video in this acid and base unit, and you probably already know some stuff about acids and bases, actually, especially maybe acid you've heard a lot about. You know that it's a chemical that can burn you and things like that, or dissolve certain substances or whatever, but there's just so much more to acid-base chemistry, and it starts here. There's actually three main definitions of acids and bases, and so some of the things that you think of as acid are certainly acids, like hydrochloric acid and things like that, that we've worked with in class before, but there's a couple other different ways to define these chemicals, okay? The first model, and probably the one that we'll talk about the most in our class, is known as the Arrhenius model. This was actually the earliest definition of acids and bases, and it has everything to do with the dissociation of compounds into an aqueous solution so that either the hydrogen ion concentration goes up or the hydroxide ion concentration goes up. And so we'll be working lots with hydrogen compounds and hydroxide compounds when we look at the Arrhenius model. We're actually going to take a pretty deep dive into this model during this video. Okay, the next model to come around was called the Bronsted-Lowry model, and this is different and similar to the Arrhenius model. The acids especially are pretty similar. This has to do with protons, which are really just hydrogen ions. You know, if you think about a hydrogen atom that loses its electron, it just becomes a proton, and so it's pretty similar to Arrhenius acids, but the proton moves from place to place. We have what's called a proton donor, and that's known as the acid. And that's pretty similar to an Arrhenius acid, actually. It gets rid of a hydrogen ion. And then we have something called a proton acceptor, and that's the chemical that proton will go to, okay? And we'll talk about that in another lesson. And then finally, the last model that we have is a Lewis acid and base. This is probably the most encompassing definition of acids and bases. It's really a general definition, and it just about covers every type of reaction, actually. And this has to do with pairs of electrons that are unbonded. They're lone pairs of electrons around an atom that go from one place to another and usually make some sort of a covalent bond. And the base is the thing that gets rid of those electrons, and the acid is the thing where that takes those electrons in to make a new bond. And we'll talk about Lewis acids and bases in another lesson as well. So let's take a deep dive into the world of Arrhenius here to begin with. So here are some properties of Arrhenius acids and bases. So we'll just start with the acids here. They have a sour taste, and lots of the foods that you eat and enjoy actually have an amount of some sort of acid in there for sour taste. Like, you know, vinegar is an acid. It's acetic acid. Citric acid, which is found in citrus fruits and things like that. Sour candies have some sort of an acid in them. Another property is that they can react with certain metals to make hydrogen gas. We've actually done this in lab, where we reacted hydrochloric acid with zinc to make hydrogen gas. This one might not make a bunch of sense, but we'll talk about it. An acid will turn blue litmus paper red, and litmus paper is what we call an acid-base indicator. It's basically just a little piece of paper, comes in either red or blue, and you dip those papers into a solution, and if the blue one turns red, it's an acid, and if the red one turns blue, it's a base. Okay, so acids and bases react with indicators. And then the biggest probably thing that we care about is that an acid will increase the hydrogen ion concentration in the water, okay? And then this low pH values, you've probably heard of the pH scale, which we'll cover in another lesson, but the numbers of acid on the pH scale are low. They are below 7, okay? And then a base has a bitter taste. These are typically poisonous. They're pretty nasty stuff, like pine needles and things like that are kind of bitter, soapy kind of flavoring. As far as the indicator goes, a base will turn a red litmus paper blue, sorry, not red. Right, and then these also react with certain metals to make hydrogen gas, and the big one is that they increase the hydroxide ion concentration in water, okay? And then in terms of pH, they have high values. They are above 7 all the way up to 14. All right, so those are some properties you need to be aware of in terms of the world of Arrhenius acids and bases. And let's talk about how these things actually work. So here is, here's a little diagram here. Let's just say that this is pure water that's in this little vessel here. And let's say that these compounds up here represent HCl. Yep. And so when you put those things into the water, when the hydrogen chloride dissolves into the water, it doesn't really dissolve, it dissociates into its separate ions. So we have our chloride ions in solution here, which we don't really care about because they're not part of the definition of an acid or a base, but these red dots here, these are the ones that we care about. And as you can see, where there was no hydrogen ions in the water to begin with, once we put that substance into the water, the amount of hydrogen ions goes up. And that's the definition of an acid. Here is the same thing happening with a base. And so let's just say another pretty common Arrhenius base is sodium hydroxide, NaOH. Okay, so when these sodium hydroxide ions dissociate from one another in the water, we get, you know, a bunch of sodium ions, which we don't care about because they're not part of the definition of these acids and bases, but they're there nonetheless. So here's the sodiums that are floating around. You could say that the sodium ion concentration is increased here, but we don't care about that. What we do care about is the hydroxide ions have increased, okay? So anything that will dissociate to increase the hydroxide ion concentration is known as an Arrhenius base, okay? So in terms of acid names, you've probably heard of a bunch of different types of acids. One that we commonly refer to is hydrochloric acid, but there's lots of different types here. So here is a list of names and formulas for a couple of pretty common Arrhenius acids. Hydrochloric and hydrofluoric. So these guys, which is just a hydrogen ion connected to a fluoride ion or hydrogen connected to chloride, when it's just a simple binary compound like this, they have their own naming system. If the name doesn't start with hydro, then it means the acid is formed from hydrogen ions and a polyatomic ion, such as these examples here: nitric acid, phosphoric acid, sulfuric acid, and carbonic acid. They're also known as oxyacids, but they have their own naming scheme as well. But if you want to put these names and formulas in your notebook, then you can always know what the formula is. And you can see that like something like phosphoric acid will dissociate into 3 of these hydrogen ions. So that's a pretty powerful acid. in the right concentration. Anyway, so when the thing that we want to know how to do mostly with Arrhenius acids and bases is be familiar with the concept of acid-base neutralization. And what this is the Arrhenius acid reacting with the Arrhenius base, and as a result of that, we make salt of some sort. Salt is actually a chemical term used to define one of the products of a neutralization reaction. And then the other product is always water. Okay, and so let's just see how that goes. So in this example, we have our hydrochloric acid, the red and the blue dot here, which dissociate into solution. Here's our sodium hydroxide, which is the yellow and green one in this example. They dissociate, and when you dump the two together, those ions will find their new bonding partner, because this is a double replacement reaction, and we end up combining the sodium with the chlorine and the hydrogen with the hydroxide, and there are those formulas. So sodium chloride is the salt that we think of most when we think of salt, but it's not the only kind of salt, that's for sure. Salt is just a term for a product of a acid-base neutralization. So let's actually do a few neutralizations here and see what we can come up with. All right, so let's try these. So knowing that these are a double replacement reaction where we have our positive, negative, positive, negative, let's take a look at how the acid here, hydrochloric acid, and the base, zinc hydroxide, let's see how they would react to form salt and water. Okay, so hydrogen, the positive is going to hook up with the hydroxide negative over here. Hydrogen plus hydroxide gives you water. That's your formula H2O, right? And then the zinc is going to hook up with the chloride ion to make zinc chloride, and those are the products. So zinc chloride is not the type of salt that you want to put on your cereal in the morning, but it is salt by definition. It's made in this neutralization reaction. Okay, and then here's the next one. We have this is called sulfuric acid. You can reference the list of names and formulas that you wrote down there. So H2SO4 combining with aluminum hydroxide. Think about how the double replacement reaction works here. And we make, of course, hydrogen hooking up with hydroxide is the water, and then the aluminum hooking up with the sulfate makes our aluminum sulfate. Okay, aluminum sulfate is certainly not the type of salt that you want to eat, but it is salt by definition here. Okay, so one other thing that we can do here is identify the acid and base based on the type of salt that is produced. So if calcium phosphate is, you were told that calcium phosphate was the type of salt made in the neutralization reaction, you can sort of backtrack and reverse engineer this reaction to see what the acid and base were that we're going to make this salt. So we know that we have an acid plus a base, which is going to yield salt and water. And I'm just going to write water for now. Okay, so we know that the products of a reaction here were Ca3PO4 2 plus HOH. Okay, there's our water. And so now all we have to do is really just kind of backtrack and figure out what the acid and base were. Remember that the base is the substance that ends with OH, and there's going to be something ahead of that. And then the acid starts with H, and there's going to be something behind that, right? And remember that these are positive and negative charges. And so let's just put things where they are going to go appropriate. The H and the OH have already been spoken for here, but the calcium being the positive, that's going to hook up with the hydroxide, CaOH2, and then the PO4, this negative ion here, this is what's going to hook up with the hydrogen. So this is PO4. We need to do some subscripting. H3PO4. So here's, it's phosphoric acid and calcium hydroxide. They are what combine to make this type of salt, okay? Alrighty, so I think that's it for acids and bases intro and Arrhenius acids and bases, okay?